Okay, this is another 3-star problem from 10th edition of Resnick Halliday chapter 21 Coulomb's law. A non-conducting spherical shell with an inner radius of 4 centimeter and an outer radius of 6 centimeter. So in my picture I'm saying that Ri is the inner radius, Ro is the outer radius, has charge spread non-uniformly. Okay, so the charge spread is not uniform through its volume between its inner and outer surface. The volume charge density rho is the charge per unit volume with the unit Coulomb per cubic meter. For this shell, rho is actually equal to B over R, right? So rho is actually dependent on the R. So as we move away from the center, the charge density decreases. So there are more charges concentrated towards the inner surface than the outer surface. And we have been given the value of B also, which is 3 microcoulomb per meter square. What is the net charge in the shell? Okay, so this is actually an integration problem. So what we have is, we can consider a shell of thickness dr. Okay, so this shaded region has a thickness of dr. So the shaded region is thickness, this thickness is dr at a distance r. So we can first find what is the volume of this thin shell. So volume of this thin shell is actually the surface area of this shell at r times the thickness. So we know that dV, which is the volume of this thin shell, is actually equal to 4 pi r square, which is the surface area of this shell at a distance r, times dr. Now once we know the dV, we can find what is the charge on this shell, which we can write as dc. So this infinitesimal charge should be equal to the charge density, which is rho, times dV, the volume, right? So what is rho? Rho is simply B over R. This is rho times dV, right? We are only writing that this is rho times dV. So this is rho and dV is 4 pi r square times dr, right? So we get dc is equal to B times 4 pi r dr. And now all we have to do is, we have to simply integrate what the total charge is going to be. So total charge C should be simply the sum of all the infinitesimal shell, from the radius Ri, which is the inner radius, to Ro of 4 pi b r dr. Now we know that 4 pi b is constant, so we can take it outside. So C is equal to 4 pi b times integration of r dr from Ri to Ro. Now this is a very, very simple integration. What is the integral of r dr? It is going to be r square over 2. So therefore we get C is equal to 4 pi b times r square over 2 from Ro to Ri, and therefore C should be equal to 4 pi b times r naught square minus ri square divided by 2, which is equal to 2 pi b r naught square minus ri square. And now we have been given the values of all the constants. We know that b is 3 microcoulomb, so that is 3 into 10 to the power minus 6 coulombs per meter square. R naught is 6 centimeter, so that is 6 into 10 to the power minus 2 meter. Ri is 4 into 10 to the power minus 2 meter, and all you have to do is just simply put values and you can calculate the total charge on this sphere.